day, listeners. My name is Audrey Poulton. Welcome to our second educational program in a series of 5 produced especially for grade 10 mathematics learners. The main aim of these educational programs is to help you to understand the difficult content of this subject better. Today we will continue our discussion about the classification of numbers. We'll talk about the different types of integers. You'll hear various examples during the following conversation. So have a pen, paper, and a calculator ready to make notes and work out the examples on your own.
Hi Susie, how was your maths lesson with your aunt?
Great! My aunt explains things in such a way that I understand it very easily.
When is your next lesson? Can I come too?
Sure, I don't think my aunt would mind. We're continuing after school. You're welcome to join us.
Thanks, I'll be there.
Hey Annie, come inside.
Hey Susie, thanks.
Good afternoon, Annie. It's nice to meet a friend of Susie. I hope you learned something new today.
Thanks, Aunt Mary. Nice to meet you too. Susie has told me so much about you.
Only good things, I hope.
For sure. I can't wait to learn more from you.
Well then, let's get started. Have a seat.
Thanks. Susie told me that you discussed rational and irrational numbers last time. She explained some of it to me during break today, so I understand them better now.
That's good. And today we're going to talk about one of the groups of numbers that falls under the category of rational numbers. There are 2 main groups of numbers under rational numbers: integers and fractions. Today we'll talk about integers.
How can we describe an integer, Aunt Mary?
Integers are all the whole numbers. They can be negative and positive whole numbers. Would you like to give me an example?
Would that be numbers like 4 and -3?
That's correct, Susie.
What about 0? Is 0 an integer?
Yes, Annie. 0 is also an integer, but it is neither positive nor negative. Let's categorize them further. Under integers, we have 2 groups, namely negative integers and counting numbers. Give me some examples of negative integers, Susie.
That would be -5, -3, -10, and so on.
Yes, Annie? What would you say are counting numbers?
They must be numbers such as 0, 1, 2, and 3.
Correct. I'm pleased that you include 0. Now I want you to concentrate on the counting numbers only. Remember that counting numbers and whole numbers are the same. Counting numbers can be further divided into 2 groups. Those groups are 0 and all the natural numbers.
Aren't whole numbers and natural numbers the same? I mean, if they're positive numbers, why are they divided into 2 groups?
You're almost correct saying they're all positive whole numbers. Remember that 0 is a whole number, but it is neither positive nor negative. So we can't include it with the positive integers. So the difference is that 0 is a whole number. For the whole numbers, you start counting from 0, 1, 2, 3, etc. But for natural numbers, you start counting at 1, 2, 3, etc.
Oh,
so that's the difference.
0 is a whole number or counting number.
But 0 is not a natural number.
Now that we've got 0 out of the way, we can continue with the natural numbers, because natural numbers have more subdivisions.
What are they, Aunt Mary?
There are actually different ways of classifying the natural numbers, like odd and even, factors and multiples, square numbers, and so on. But one very useful way is to separate them into prime numbers and composite numbers.
So the number 1 is on its own, like 0? 1 is a special number with many unique properties, so we place it on its own, just like we did with 0.
1 is neither a prime number nor a composite number.
What's the difference between a prime number and a composite number, please? I know we learned them in grade 8, but I have forgotten them.
A prime number has only 2 factors, and a composite number has more than 2 factors.
What do you mean by factors, Aunt Mary?
A factor is a number that can divide exactly into another number without having a remainder. Look at the number 3. Which numbers can we divide 3 by without having a remainder?
1 and 3.
That's correct. And how many factors does this number 3 have?
2 factors. So, 3 is an example of a prime number.
Good. All the prime numbers have only 2 factors. The factors are the number itself and 1, because any number can be divided by 1 without having a remainder. Can you give me all the prime numbers less than 10?
3, 5, 7.
But that just sounds like all the odd numbers.
No, not all the odd numbers are prime numbers. Look at the number 9. What are the factors of 9?
1, 3, and 9.
Yes, and how many factors is that?
3 factors.
So
9 is not a prime number? But what about the number 2?
you tell me. How many factors does the number 2 have?
The factors of 2 are 1 and 2, which makes it a prime number.
Yes, 2 is the only even prime number. All the other prime numbers are odd, but not all odd numbers are prime numbers. Give me some more prime numbers between 10 and 20.
11, 13, 17, and 19. So the first 8 prime numbers are 2, 3, 5, 7, 11, 13, 17, and 19.
Correct. When you have to identify a prime number, you have to test it and see whether it has 2 factors or more than 2 factors. If it has more than 2 factors, it's a composite number. Now think of some composite numbers less than 10.
Not 1, not 2, not 3, 4, 6, 8, and 9.
Yes, so you can test each of them by finding the number of their factors. What are the factors of 6?
1, 2, 3, and 6, which gives us 4 factors.
Good. So next time, you'll not make a mistake with prime numbers and composite numbers. Let me ask you another question. What are the prime factors of 20?
I don't understand. What do you mean by prime factors?
Okay. Write down the number 20 and list all the factors of 20.
Factors are those numbers that we can divide 20 by without having a remainder, right?
Yes. Did you write them down?
Yes, I have. The factors of 20 are 1, 2, 4, 5, 10, and 20. Is that correct, Aunt Mary?
Yes, dear. That's correct. The factors of 20 are 1, 2, 4, 5, 10, and 20. Now I'll give you a moment to circle all those factors which are also prime numbers. Annie, what's your answer?
The prime factors are 2 and 5.
That's correct. To define prime factors, we can say that prime factors are the factors of a number that are also prime numbers. Let's do another example. I'm going to give you a larger number. Write down all the prime factors of 54. I'll give you a few seconds to do that. Okay, Susie, your turn. What's your answer?
The factors of 54 are 1, 2, 3, 6, 9, 18, 27 and 54. So the prime factors will be only 2 and 3.
That's right, Susie. So remember that factors are always in pairs. If you know one of them, you can find the other. 54 divided by 1 is 54. 54 divided by 2 is 27, and so on. The factors are 1, 2, 3, 6, 9, 18, 27 and 54. And the prime factors are 2 and 3. Okay, girls, that's all for today. So listeners, I hope you could follow the discussion about integers. Let's recap. Rational numbers can be subdivided into integers and fractions. Fractions include the proper fractions, mixed fractions, improper fractions, and terminating and recurring decimals. Under integers, we have negative numbers and counting or whole numbers like -3, -2, -1, 0, 1, 2, etc., etc. The whole numbers, which are the counting numbers, include 0 and the natural numbers, which start at 1. Natural numbers can be subdivided into 1, prime numbers and composite numbers. The number 1 is neither prime nor composite. Prime numbers have only 2 factors, whereas composite numbers have more than 2 factors. An example of a prime number is 3. We said that prime numbers have only 2 factors. The numbers that 3 can be divided by are 1 and 3. Therefore, 3 is a prime number. Another example of a prime number is 17. The only 2 factors of 17 are 1 and 17. We can also say that the factors of a prime number are always 1 and the number itself. The first prime numbers are 2, 3, 5, 7, 11, 13, 17 and 19. Let's look at the composite numbers. A composite number has more than 2 factors. If we look at the number 6, the factors of 6 are 1, 2, 3 and 6, which gives us a total of 4 factors. Therefore, the number 6 is a composite number. Just be careful with the number 1. The number 1 is neither prime nor composite. It has only one factor, which is 1. Many students make that mistake in their exams. 1 is not a prime number. This brings us to the prime factors. Prime factors are those factors of a certain number which are also prime numbers. If we look at the number 20, we can list all the factors of 20. The factors of 20 are 1, 2, 4, 5, 10 and 20. Now, if we select those factors that are also prime numbers, the prime numbers are 2 and 5. Listeners, that concludes our program for today. I hope it helped you. Thanks for joining us today, and remember to tune in again. From me, Audrey Poulton, goodbye.
This program was brought to you by NAMCOL with funding from the Ministry of Education, Arts and Culture and the Commonwealth of Learning.